time.
I did have plenty of time. All right, here we go. Section 1-4 again, right? This is what, like the second or third time now? So whatever you want to call it. Just call it section 1-4. We're going to do a thing called factoring trinomials now. I think we've kind of labeled everything up to this point, so let's label it again before we even start. So it's called factoring trinomials. Now we talked earlier in the year about what a monomial, binomial, trinomial is, correct? So this is what we're going to do. Actually, let's start backwards. We've kind of done this. When we did greatest common factor, we kind of started backwards. We started off with a multiplication problem and then said, okay, what we're going to do for factoring is we're going to go backwards and we're going to start with our answer and then end up with our question. Do you remember talking about that? We're going to do the same kind of thing here. So let's see. I'll start off with a real basic one. And x plus, I don't know, let's say 5. So I'm going to start off with multiplication. This is not factoring. This is already factored, right? Those are the two factors. Remember what factors are. They're the things. It doesn't have to be 2. I think yesterday I said they have to be 2, but they don't. They could be any amount. But right now, it's two things that are being multiplied together. So the things that are actually being multiplied together are called our factors. The answer is called a what? Product. Good. Okay, so what I want to do right now, I'm going to start with my factors and get a product. But what they're going to do on the problems, they're going to give you a product. They're going to give you kind of like the answer, and you got to figure out what is being multiplied together in order to get that answer, okay? And that's what it means by factoring. All right, so this is kind of starting backwards, and I just want to show you just a little pattern here. All right, we'll start with two positives, and then we might change it up, maybe do a positive and a negative, and then maybe a couple negatives just to see what it looks like. So let's just do this. This is just distributive property, or we learn what's the other method that we learn? FOIL. Okay, so we do FOIL method, or you could just look at it as distributive as well. So do the first, and then do the outside plus 5x, then do the inside, which is plus 2x, and then you do the last, which is plus 10. You don't leave it like that, do you? On the quiz, on a couple of those problems, some of you guys, you get like added or subtracted, you got this big long string of things, but there were things that you needed to add up. You've got to add up the like terms. If you don't add up the like terms, I'm going to mark it wrong. Even though that multiplication was correct, I want you to simplify it. That is part of what I want you to do when you do these problems. So if you don't simplify this, I will mark it wrong. Is that understood? Even though you did the multiplication right, I still want you to simplify. So that's x squared plus 7x plus 10. Alright, so there's our answer right there. What I want us to do is I want us to see, I'll tell you what I'm going to do. I want all this on one line so we can, oh, maybe that didn't work. Let's see if I can grab something here. There we go. I'm just going to scooch that over a little bit and then scooch this over. Tell you what, let's do this. Get rid of that. Put this up here like that. Good? Because I want us to see a little pattern. Because I think from now on, I don't know if we have to even write out the steps. I think you should be able to do that in your head, don't you? Outside, inside, so 5 and 2, which is 7. Everybody see that? So let's try that again. But let's do this. I'm going to keep the same numbers, but let's make one of them negative. Let's make this one negative. Right? And let's see what we get. So it's just FOIL method. So it's going to be x squared, then the outside and the inside. So the outside is negative 5x. Let's just kind of remember this for a second. So the outside is negative 5x, the inside is positive 2x. So it's negative 5x plus 2x, which is negative 3x. All right? And then we do our last term, which is minus 10. Let's do this again. Let's change up the positive and the negative. I want to do kind of like every scenario for this that I can do. So let's do it again. So it's going to be x squared again. And look, outside, that's the same thing. Of course it is. Again, it's one of those days. Let's make that minus and make that plus. All right, let's try this again. Thanks for bringing that to my attention. So we've got x squared, and what? The outside is plus 5x, the inside is minus 2x. So this time it's positive 5x minus 2x, which is plus 3x, and then minus 10. Everybody see this? And let's do one more. So I've got x, so I went two positives, I went a positive and negative, negative, positive, so now what do you think I'm going to do? Negative, negative, very good. So I'm going to go negative, negative on this. Alright? Did she keep quick? Yeah. Okay, thanks. Alright, so let's do this. So we multiply it together, we get x squared, Then the outside is negative 5x. The inside is negative 2x. So it's negative 5 minus 2. What is that? It's negative what? 7x. And then what's this going to be?
10.
What 10? Positive 10. Right, plus 10. What I want us to do, I just want to see us to see just a little pattern here. All right, let's take a look. The first and the last was easy. Okay, every one of these started off x squared, didn't it? Because it always started off with a positive x and a positive x, every single one of those, so it's always going to be positive x. Look at the last terms. All you did was multiply to get this last number here, didn't you? Everybody see that? But what'd you do to get the middle number? Look, I've got every single one of these is a different number, isn't it? All right, because I got a positive 7, a negative 7, a positive 3, and a negative 3. So how did you get these? Instead of thinking FOIL method every time, basically all I had to do was take these two numbers, the 2 and the 5, not multiply them to get my middle one, but do what to it? Add them up. Okay, so I add them up, and that's what's going to be in the middle. So after you get used to this, multiplying binomials like this, it's actually kind of easy. Just add these two numbers up, and that's what's going to be in the middle. Everybody see that? So 2 and 5 is 7. Watch. 2 plus negative 5 is negative 3. Negative 2 plus 5 is positive 3. Negative 2 plus negative 5 is negative 7. You see how that works? What I want you to do, though, is I want you to use that because we're going to go the other way. Remember? We're going to go from the product to the factors. We want to factor this stuff. So I'm going to start here, and I look at this. They all have the same pattern, don't they? They all go x squared, then x, then a constant, every one of these. So when you see something that needs to be factored, and you see x squared, something x, and then just a constant, that automatically tells you that, hey, I'm going to try this trinomial factoring. All right? So this is a trinomial, isn't it? 3 terms. So what should it look like? It should look like this. So as soon as you see a trinomial, start thinking, oh, this is one of those that fits that pattern, so let's put 2 parentheses here. Now let me warn you though, you can't factor every single trinomial, even if it's in this form, even if it is something x squared, something x, and then a constant. Not every single one of those situations can you factor, and we're going to learn how to deal with that a little bit later on. But the problems they're going to give you in this lesson right here, you'll be able to factor every single one of them. All right? But in, like, quote, real life, you're not going to be able to factor everything. But they rig these all for you so you can factor them. So what are we going to do? Now, we want to eventually get to this. And I'll keep this up here. Just kind of like push this off to the side of your mind a little bit. But you know it's there. So what do you do? If I gave you something like this and I said factor this thing right here. First thing you do, you say, oh, that's one of those trinomials. It's x squared, x, constant. If you have that situation, I know right off the bat I'm going to put 2 parentheses. Everybody with me? So now what do? We say this times this has to equal x squared. So what's going to go here and here? It's going to be x and x. Remember doing this in Algebra 2, don't you? Probably did a little bit of it in Algebra 1. Chances are you probably didn't understand it that well in Algebra 1. Algebra 2 it started making a little bit more sense. Maybe you forgot it, and now it's just one more chance to make sure we get this before you go to college, and they expect you to be able to do stuff like this. Even in just a general math class, even if you're not majoring in something that's math related, you'll have classes where you'll probably have to do this kind of thing. All right? Even if you're taking like elementary ed or something, you'll probably have to take like a college algebra type of class. Okay, it might be the toughest class that you take, even though it's an entry-level class, but you'll still probably have to do this. All right, now, look at this. This is what I do now. I look at my signs. If you look at this, they're both positive, so that's positive. Positive, negative, that's going to be negative. You follow me on that? So, look, this thing is positive, and this is positive, so I got 2 choices. They're either both positive or they're both what? Negative. But when I add them up, I get a what? Is there any way I can add up 2 negatives and get a positive? No. So what do my signs have to be? They got to be positive and positive. Does that make sense? All right, so that's what I do first. I always do my signs first. I think that makes things a little bit easier. Now what I have to do is look at this. Remember I said the 2 times 5 is 10, and then the 2 plus 5 is 7? So these 2 numbers, they do 2 things. They multiply to become this last number, and they add up to become the middle number. Isn't that true with all of these? Look, they multiply to be negative 10, add up to be negative 3. Same thing here. Multiply to be negative 10, but these add up to be positive 3. Multiply to be positive 10, and they add up to be negative 7. So that's what we have to think. This is where the thinking is involved. We have to think what number, or what times what, doesn't have to be the same number. Well, what times what is 10? But those same two numbers also add up to be 7. Well, 5 and 2, right? Now, it doesn't really matter in this case which order you put it. You could put 2 and 5, or you could put 5 and 2. It doesn't make any difference because they're both positive. And there you go. You just did your first factoring of, well, trinomial factoring of the year, right? And you've done this before. It's not the first time you've ever done this, but that's what we do. Now, this really helped because it was all off to the side, wasn't it? All right, but sometimes you gotta think of it on your own. So they start off with this thing in the box, and they expect you to get to this. So this is your answer. When they say factor this thing right here, it needs to look like this problem right here, or this answer: x plus 5 times x plus 2. And you might be saying, well, why did I put x plus 5 first? I don't know. I just thought 5 times 2, right, instead of 2 times 5. That's all. It's no big deal. Does that make any sense at all? All right, let's try one from scratch. I know this might be routine for you, but I just have a feeling that it's probably good for us to go over some of these, don't you? Because it's been a while since you've done this stuff. Now, in this book, I'm finding it hard to find some of these easier ones, okay? Tell you what. All right, let's try this one. What they say is to factor. All right, that's what we're going to do with this. So, is it in that form that we, that trinomial factoring form? Yeah, because if you have it in x squared, if it looks like something x squared plus something x and then a constant, then that's the form that we want to use. So if it says to factor, we should be able to factor it. So first thing as I, first thing I do is I put my two parentheses there. Let's look at the sign. Well, let's do the x's first. We can always do that, can't we? Because the first one times the first one equals x squared, so this must be x times x. What about the signs? Let's do the signs first before we worry about sticking numbers in there. All right. So they multiplies to be negative, right? And it adds up to be positive. So if they multiply to be negative, one sign has to be, what do you think? Positive, and the other sign has to be negative. They can't both be positive, right? Because you can't get a negative answer if you multiply two positives together. If they both can't be negative, because if I multiply two negatives together, right, I get a positive. So it has to be one positive and one negative. Everybody good with the signs so far? Now what do we have to do? This is the thinking part. Remember, these two numbers multiply to be negative 12. And they also do what? To be 1. They add up to be 1, don't they? Right? Because that's the coefficient of that x. So you got to think, okay, what times what is 12? Well, there's a couple things. Well, actually, probably three things.
3 and 4.
Okay, there's 3 and 4. What else could there possibly
12.
be? No, you can say
6.
12. 12 and 1 is a possibility, or 2 and 6, right? 6 and 2. All right? You've got those three possibilities, right? But you got to pick the one that will add up, one being positive, one being negative, add up to be a positive 1. Can you get 6 and 2
No.
to add up to be a 1, even if, you know, positive is negative? No. What about 12 and 1? Can you get that? No. So what's our other choice? 3 and 4. Now, does it matter where we put the 3 and the
Yes.
4? Right. If we have positive and negative, it absolutely matters. If they're the same sign, did it really matter? No, it didn't matter. But if they're different signs, it absolutely matters. It has to add up to be a positive 1, so the bigger number has to be what? Positive. So if I use 4 and 3, the 4 has to be positive and the 3 has to be negative. Does that make sense? So just check it. Do a FOIL method. X squared negative 3x plus 4x is positive 1x. Yep, sure is right there. And then you multiply the last. It's negative 12. There we go. And we have factored. And that's what your answer should look like. Just like that. Make sense? All right, what if you have something like this, though? Because the problems they're going to give you. Let me check the worksheet. Yeah, I give you one that's like this, but then I give you 1, 2, 3, 3 of them that are like this problem right here. What if we did this? What if I said like 3x plus 2? Let's just go x minus, I don't know, 5. We'll use that 2 and 5 again. It's a little bit different. What's different about this compared to what we did earlier?
There's a constant in front.
Yeah.
Of,
well, it's not a constant. It's a coefficient. Right. It's a coefficient right there.
Why do I say constant?
Well, because it starts with a c. Right. So let's do distributive property on this. This is a little bit different. Now watch. It's kind of the same, but what do we get? 3x times x is 3x squared, right? Then the outside is negative 15x. I'm not going to try to do this in my head. This is a little bit more complicated. So, and the inside is plus 2x. And then the last is negative 10. All right? So let's simplify this. That's 3x squared minus 13x minus 10. Right? So that's what this is right there. But let's be careful with this. Remember we said on these problems up here, if I took the last two, they multiply to be the last number, and that's true with this, isn't it? Okay. And then the first multiply to be this. But look, can I just take 2 and add it to negative 5 and get that? No, because look, 2 plus negative 5 is not negative 13, is it? So you got to be a little bit more careful on these. Okay, when you have a coefficient out in front, these are a little bit trickier than what these are right here. But really, it kind of works the same way, because how did you get this number? Well, I took the outside and the inside, right? I multiplied the outside together, multiplied the inside together, and added them up, and I got this middle number right here. So this is a little bit more complicated. So watch. 3x times negative 5 is negative 15, right? Plus 2x is negative 13. So the outside and the inside add up to be the middle term. So what we have to do is we have to start with this. Oh, yep, x minus 10. We have to start with this and then figure out what's going to go in the parentheses. Let me scooch this up. So now I know you already saw it. You might have even written it down. But I'm just going to move it. Scooch that over. I'm just going to move it so we don't see it right in front of us. So what do we have to do? We got to think this times this. It's kind of like the backwards FOIL method. I've heard a lot of people say that, and that's an okay way to think of it that way. It's kind of like the backwards of FOIL, right? So what do? This times this has to be 3x squared. Well, there's really only one choice. There's 3x and there's x, all right? Now, some problems are a little more difficult. It could be like 8x squared. So you got different choices, don't you? You've got 8 times 1, or you have 4 times 2, or you could mix it up and go 2 times 4, right? So if you have a number that's not prime, you may have different choices that go there. And so you might have to try this over and over again until you get it right. This is kind of like trial and error a little bit. And not today, but maybe tomorrow I'll show you another way to do this. Some people like it, but there's quite a few steps you have to do this. But let's do it this way. Let's do the signs now. The signs still work the same way. It multiplies to be negative. So what are my signs going to be? Plus and minus. Now here's the kicker, okay? It's this times this has to be a negative 10. Well, you got a couple choices. You've got 5 and 2, or you have, what else? 10 and 1, right? You got 10 times 1, or you got 5 times 2, right? And you could have like positive 5, negative 2, or you could have positive 2 and negative 5, right? So there's all these different options that you got to throw in there and see what works. Now, we've already seen the answer, but let's just pretend we didn't know what this answer is. Let's just say, let's try 5 and 2. So let's put a 5 and a 2 right here. Let's see what that does for us. All right? How do we check to see if that's right? Just do the FOIL method. Or we know the first works and we know the last works. It's the outside and inside that we got to check. So what's the outside? If I multiply the outside, what do we get? Negative 6x. And if you do the inside, that's positive 5x. What's negative 6 plus 5? It's negative 1. Is that negative 1? No, so that doesn't work, does it? So we got to try something else. All right? So let's get rid of those and try it again. Sometimes you might try it 2, 3, 4 times until you get it. Sometimes you try it and you get it in the first shot. All right? What's another possibility that you might think of? I tried 5 and 2. Let's try what? 2 and 5. Let's try 2 and 5 and mix it up a little bit. How do we check to see? Take the outside. What's that? Negative 15x, right? Multiply them together. And then what's the inside? Positive 2. What's negative 15 plus 2? It's negative 13. That works, doesn't it? Does that make sense? Okay. Sometimes it's a little bit tedious because you got to try it over and over again. Let's try another one. Let's try one right from the book. Here we go. 4x squared minus 11x plus 6. Alright? Let's just try this. I'm going to do it underneath it here. It says to factor it, and it's a trinomial, so I'm going to put my 2 sets of parentheses. Now I've got a couple choices here with 4. What could I put here? I could put 4x and 1x, or what's my other choice? I could use 2 and 2, couldn't I? Again, it's just a shot in the dark, okay? Just try one. What do you think you want to try? 4 and 1? Okay, let's try 4x and 1x. All right. Now, what about my signs, though? I can be good on my signs. They multiply together to be a positive 6 and add up to be negative. So, are they both going to be positive? No, because I couldn't take two positives and get a negative out of it, so they have to both be negative. So, I'm good with my signs. I know that's going to be good. I'm not sure if there's going to be 4 and 1. It might be a 2 and 1. Or, I mean, sorry, 2 and 2. Right? But we won't know until we start. Now, I got a couple choices with 6. I could put 6 and 1, or I could put what? 3 and 2. Or I could put 2 and 3. Do you see all the different possibilities there are? You might get lucky and get it right away. But we just got to keep trying. So what do you want to try? What do we want to put here and here? Come on, talk to me. We don't have time. We don't have time. Nobody's going to give me a possibility. Let's just try 3 and 2. All right? Let's stick this in there. Now, we know the first works, right? Because 4x times 1x is 4x squared. We know the last works because negative 3 times negative 2 is positive 6. It's that middle one. How do we do the middle one? Well, we check it. Let's do the outside. What's that? That's negative 8x, isn't it? Oh my gosh, we got it in the first shot, didn't we? I didn't really want to get it in the first shot, to tell you the truth. But we did. And that was kind of nice. So look, 4x minus 2 is negative 8x. This is negative 3x. What's negative 8 minus 3? It's negative 11. That's what we have right here, isn't it? Bang. We got it in the first shot, didn't we? Let's pretend, though, we didn't. All right? Let's pretend we went like 2 and 2. I just want to show you, because most likely you're not going to get it in the first try. So watch. Here, let's put 2 and 2. Do we know if this works or not? Look, 2x, what do we do? Try the outside and inside, right? So 2x and negative 2, that's negative 4x, and this is negative 6. Negative 4 minus 6, does that work? No, that's negative 10. It doesn't work. So what does that tell us? That tells us we need to try something else. All right? So maybe you thought, well, I kind of like the 2 and 2, but let's switch this one up. Does that work? That's negative 6x minus 4x. That's still negative 10x. Doesn't work. So you kind of see what works and what doesn't work, okay? Now, what you're going to do tonight is you're going to finish up that worksheet, okay? So that worksheet I gave you yesterday, do to the end. What does it go up to, like 10 or something like that? All right, so do up to number 10, and that's all due tomorrow, and we'll go over it tomorrow.